What if everything we think about when to replace water system assets, like pumps, pipes, and tanks, is completely backwards?
Wait, really? You mean all those plans based on how old something is might be off?
Exactly. For decades, utilities have been planning replacements based on an asset's age, assuming things fail just because they get old.
Huh. I always thought that made sense. Like, stuff just wears out after a certain time.
That's the common belief. But in reality, assets don't fail just because they're old. They fail when they stop performing well.
So it's not about how many years something's been around, but how well it's actually working.
Right. And why this matters is huge. Misusing age as a guide leads to wasted money, unexpected breakdowns, and risks to public health and service reliability.
Wow, that sounds serious. So what will we learn here?
By the end of this episode, you'll understand why age is a poor predictor of failure, what really matters in managing water system assets, and how small utilities can make smarter, risk-based decisions.
Okay, I'm intrigued. So what's wrong with this useful life idea everyone uses?
Well, the industry often assigns a fixed useful life to assets, like saying a pump lasts 20 years, a tank 30, and so on, and plans replacements around those numbers.
That sounds straightforward.
It does, but here's the catch. Useful life means different things depending on who you ask. Engineers think of it as a theoretical lifespan under perfect conditions. Accountants use it for depreciation schedules. Regulators have their own timelines tied to funding and compliance.
So, 3 different definitions that don't really line up?
Exactly, and utilities often treat them as the same, which leads to poor decisions.
I see. And age is easy to measure, but it doesn't really tell you if something's about to fail?
That's the big problem. For example, a 10-year-old pump running under tough conditions might be closer to failure than a 30-year-old pump that's been well maintained.
That makes sense. So relying on age can mean replacing stuff too early and wasting money, or waiting too long and risking failures.
Yes, and for small utilities with limited budgets and staff, those mistakes are even more costly and disruptive.
So, what's the better way?
Lifecycle Asset Management. It's a continuous, integrated approach that focuses on how assets perform over time, not just how old they are.
How does that work?
Think of the asset lifecycle as a loop. Plan, design, build, operate, maintain, renew, or replace, then back to plan.
So it's not just about replacing things on a schedule, but constantly checking how they're doing?
Exactly. And these phases shouldn't be separate silos. They need feedback loops, so information flows back and forth.
That changes the question from when should we replace this to how is this asset performing right now? What's the risk if it fails?
Right. Performance becomes the key metric. Things like flow, pressure, reliability, and compliance. Not just age.
And this works even for small utilities without fancy software or big teams?
Absolutely. It's practical and scalable.
Okay, but not all assets are equally important, right?
Correct. That's where asset criticality comes in. It measures how important an asset is based on the impact if it fails.
So it's not about size or cost, but about consequences.
Exactly. Risk equals likelihood of failure times consequence of failure.
For small utilities, consequence often matters more because they have less backup and redundancy.
Right. For example, a small valve that isolates a system section might be more critical than a large pump, because if it fails, repairs become impossible.
Or a newer chlorine system might be more critical than an older storage tank because failure risks public health.
Exactly. Criticality helps focus limited resources on what matters most, avoiding wasted effort on low-impact assets.
So once you know which assets matter most, you need to know how they're doing.
Yes, that means understanding condition and performance.
Condition is the physical state, like corrosion or wear, and performance is how well the asset does its job, like flow or pressure.
And remaining useful life isn't a fixed number. It's a dynamic estimate based on condition and performance.
Visual inspections alone aren't enough, because many failures happen inside or gradually without obvious signs.
Exactly. Simple, repeatable assessments and performance tracking, like monitoring flow or energy use, give real evidence.
So a pump with stable flow and pressure is healthy, even if it's old. but one with declining flow and rising energy use is degrading.
That's right.
But here's a big problem I've seen. Field data often doesn't reach the people controlling budgets and capital plans.
Yes, that communication gap breaks asset management. Operators see problems, but leadership sees budgets disconnected from reality.
So what's the fix?
Create a clear communication pathway where asset health data is summarized and translated into understandable risk and financial impact for executives and boards.
Like instead of just saying pump condition is poor, explain, this pump is likely to fail within 1 to 2 years, risking service outages and costing roughly X dollars to replace.
Exactly. That makes decisions defensible, transparent, and aligned with regulatory expectations.
So to wrap up, age alone is a poor guide. We need to focus on performance, condition, and risk.
Prioritize assets based on criticality and consequences of failure.
Use real data from the field to guide decisions.
And close the communication gap between operations and leadership.
Smarter asset management means fewer surprises, better use of limited funds, safer water systems, and more sustainable utilities.
Next time, we'll talk about how to build practical maintenance programs that actually work in the field.
Looking forward to it.